Right, so we go on to question 7. So they say to us, an experiment is set up as shown in the diagram below to investigate the effects of slit width, right, and the degree of diffraction. They say distance y on the diagram represents the distance between the screen and the single slit, and distance x on the diagram represents the width of the central bright band. Right, now firstly, they say to us write down an investigative question for this experiment. Now, remember, ladies and gents, what are we trying to find out, right? The relationship between the slit width, right, and the, well, let's say the distance of the central bright band, okay? Or you can say, in this case, the degree of diffraction. Right, so in this case, they say to us we should write down the investigative question. Right, we can say, how will the slit width affect the angle or the width of the central bright band, right? So remember that an investigative question cannot be answered with a yes or no, or must not be answered with a yes or no, meaning you must answer you must ask an open question, and please do not forget to have a question mark at the end. Otherwise, then it does not become a question. Right, now they say to us we must state Huygen's principle. Right, so please remember, we say that Huygen's principle simply says every wave of a wavefront, right, serves as a point of a secondary wave that moves forward with the same speed as the wave, right? It is one of those principles that we must know. Okay, right. So let's go to the next question. They say, how will the distance x be affected if the slit width is increased? Choose increase, decrease, or remain the same. Now remember, ladies and gents, that the formula that we use, and I know that it's not given, right? Okay, so this is the formula that we use, right? So in this case, this would be the mth dark band, right? So in this case, because we're looking at the central bright band, our m value is 1, right? This is the wavelength of the source of light that you are using. And now this is the width, the slit width, right? Now, notice, ladies and gents, that it is in the denominator. Now, if we increase the slit width, what happens in this case? It means that we are going to decrease that sine of theta, meaning that our angle will actually get narrower or will get smaller, right? So they said to us, if it is increased, then we know that it will decrease. And they say explain our answer. We can say that slit width, okay, is inversely proportional right to to the distance, or in this case the measure, we said the width rather, of the central bright band of our central bright band. Okay. All right, ladies and gents. And finally, they say, how will a distance x be affected? Okay, so they want to know about that bright band. If distance y is decreased. All right, now this one goes without saying, ladies and gents. The further away I actually put this, in this case, it means that my diffraction angle would actually be, would increase. So they said choose from increase, decrease, or remain the same. It will definitely increase. Okay, right, so there's not much calculation here, right? So let's go on to question 8.